What we're looking at here today is the Keen engine, made in the early 1950s by Charlie Keen, K-E-E-N, out of Madison, Wisconsin. And he spent a lifetime making this, put it in a car. It is 100 cubic inch displacement, turns out 140 horsepower, and was considered to be one of the most efficient engines ever. It is quite obviously a V4 engine on a 90-degree V4, and it is based on the center part of a small block Ford 272 crankshaft. And the center two throws, it ends up being a flat crank, which is very important that you have a flat crank, because when you have a V4 and a flat crank, you end up with it having self-starting capabilities. Another interesting aspect of it is that it is designed very cleverly so that with the flat crank, it is offset. The valves are offset just ever so slightly. They're offset the width of the big end of the connecting rod, because you have two connecting rods on each journal bearing. And that has great relevance. And later on we will look down here and we will see that in the center of the V we have the cam is down in the V, very much like the early flathead Fords had. And you will notice that the push rods line up, because they're offset slightly, they line up on the same cam. And this also has a sliding cam. It has 4 different cam grinds, and so you can go from very long cutoff, forward and reverse, to when you're going fast and you want to be efficient, you can go to a very short cutoff and get much better steam fuel economy. So we have the cylinders here with the pistons. We have poppet valves in here being operated by the cam and the push rods coming up here. And we only have intake valves with the poppet valves. The steam comes in here, gets distributed through here into the steam chests that are here. Ideally in steam you want very little clearance volume, and you want a very short passageway between the valve and where the steam goes in, which is right there straight into the head. Now, this is a uniflow, and the exhaust comes out of these holes right here, which go into the side of the cylinder. Well, the cylinder only has sides. And so what happens is the high pressure steam goes in here, pushes the piston down. The piston goes just past the holes that are drilled into the sleeve, and the steam exhausts out through little manifolds, and then most of the steam comes out. Some is left in the cylinder, which is recompressed when the piston goes up, which is okay. Now, this has a very, very fascinating little business here. And what happens is these are very small auxiliary exhaust valves. These are little poppet valves which fit into the inside of the cylinder up here, and they only are pushed in. Pushing in opens them when you're at very long cutoff, forward and reverse. And most of the time they are left like this out here, because then the pressure holds the little exhaust valves closed, and that's the way they run when they're going at high speed. You only need an auxiliary exhaust when you're at full cutoff and you're going very slow, starting out, going either frontwards or backwards. So this is quite interesting to see how a regular automobile engine is modified to make a steam engine. Here only the crankshaft is from the original Ford. The crankshaft, the connecting rods, and the pistons are the only part of the original Ford that is used, because those things are difficult to make by hand. Everything else is either a weldment or a casting. The other clever thing that Charlie Keen did is he figured out how to make one pattern for one cylinder head, steam chest, poppet valve, the whole business. You made one, and then you put 4 of them together, and they're all identical. These are offset this way. You come to this side, they're offset slightly the other way, because, as I mentioned, you want both cam followers to be running on the same cam. This also has, quite interesting, it has a sliding camshaft with 4 different grinds of cams in it. 1 reverse, full cutoff, 1 to start, full cutoff, and then 2 intermediate and very short cutoff for once you're going. So the fact that this thing works is the miracle. It has several thousand miles on the car. Charlie Keen had it. He was always working on it, perfecting. It ran at fairly high pressures and temperatures, more or less 800 psi, 800 degrees F of the steam, and it was very efficient. In use, once everything was working, this was all covered with a big insulating cover, and then that made it work better. The boiler was a Doble F boiler. Charlie Keen hired Abner Doble in the late 40s to design the boiler for him. And so he made 3 boilers, 2 of which I own, which are floating around. They're basically a Doble F boiler. Doble was working in Milwaukee at the time. Some of the big steam companies, and so he was available, and Charlie's brother was in Milwaukee, contacted Abner. Abner designed the boiler, and so it ended up being one of the better modern steam cars.